So one of the board which we made, which is this one, the RGB LED, is basically from one of the class. So the way it's organized is every week you learn something, and then you do something. So 1 week you will learn project management, 1 week you will learn electronics production. So all the thing which we did in 1 day is basically what you do in 1 week. Then you learn computer controlled machining, then you learn electronic design, which is basically using Eagle and using the Eagle to make your circuit and then making the board. Then 1 week you do molding and casting, 1 week you do embedded programming, composite, input devices, output devices, networking, and all those things. So what we did is today is basically we shrank 3 different week. So one was electronic production, other was electronic design, and then embedded programming. We basically are covering this. So what we did so far is electronic production, which is basically milling your board and then stuffing it. Then you have electronic design, where you use Eagle and use the Eagle software to make your circuit and then make the file that can then be used to make board. And the third one is embedded programming. So what I'm going to show you now is embedded programming, where I'll just give you a little bit demo of programming it, writing a small code and then burning on it. Again, the entire process takes 1 week. I'm just going to quickly copy paste the code and then run it. So for this you can use multiple platforms. The one I'm using right now is Atmel's own software, which is Atmel Studio. You can download it for free. Just Google Atmel Studio 6.0 and you can download it. And the board we are doing again is in output devices. We have one board called RGB LED. So we actually made this board. So this is this board, and if I go to board part of it, yeah. So this is the connector which is used for power supply. So I'm holding my board like this. Over here is my ATtiny44 microcontroller. This is my RGB LED, and this is the power connector. Now power connector, you can see that this line is voltage V and this is ground. So that I can connect with this. So this is my connector. Over here I have connected the positive side of it, which goes to 9-volt battery. The black one is the negative part of it. So this again, it's very important to keep the orientation in mind. If you flip it, you can probably short the device or something. So I'm just going to keep it like this. Now this board is already programmed, that's why it's doing all the RGB LED thing. But this Daniel's board is not yet programmed, so I'm just going to program it as a demo. So all you do is connect it. So now the board is powered. So if you look carefully, initially it says that there's a red LED here, which means the board is not powered yet. But when I plug in, I get this green LED, and the green LED specifies that the board is actually powered now. Now I can go back here, ignore this. So the way to create project is just go to File, New, Project. You're gonna create GCC executable. You can name your project. So I'll just say RGB Hello 2, because I already have RGB Hello, and then just click OK. It's going to ask you which microcontroller you are using. So which microcontroller are we using? Okay, T45. So I'm quickly going to go to let's select ATtiny and then ATtiny45, this one. So once we do it, it creates a sample C file, which is this. Now this C file doesn't do anything right now. So to compile it, I can just compile it from here, and it will compile and it will say it's successful. Now once you compile it, what it does is it converts the C file into a hex file, and that hex file you can download into your microcontroller. So for now, what I'm going to do is I'm just going to go to the website, and Neil has already written a C file. So I'm just going to go and copy paste it. So let's first save it, then open it. Yeah. So all I did is I just copy pasted that file. Now I can compile it, again, all these commands are a week of work, like every syntax and everything you need to learn, and that's specific to particular microcontrollers family actually. So I'm just gonna go and program it. Now it's throwing me an error that is the CPU frequency. So there is a way to define it here. You don't need it because we are using the default frequency. And again, it's a warning, so you can ignore it. So I will go back to my folder where it created the C file, hex file. So it's Atmel Studio 6.2. This is my project. Inside the debug folder, it creates something called hex file. And it's this hex file which we're going to transfer from the computer to our microcontroller board. Now to do that, the software already has device programming capability. So just open, again you go to tools, device programming. Here you have option to select which programmer you are using. So right now we are using Atmel ICE. It can be USB Tiny, it can be AVR, any other ISP devices. The microcontroller we have here is ATtiny44, and the interface we are using is called ISP. It's called in-system programming. Just click apply. Then this two things actually tells you if your board is working or not. So first I'm going to read the target voltage. It says 4.9 volt. What it says is that my board is actually getting some power. The second thing I'm going to do is I'm going to read the signature. So this will actually communicate with my microcontroller and then get the signature information from it. If this step is successful, then it tells me that my board is proper and it's working properly. If it's not successful, then probably something is wrong with my board. So I'm just going to go and read, and it's reading the signature. In most of the cases, it will read it. If there's some short circuit or some problem, that it won't read it. So now that is done, I can simply go and program my board. So I can go to memories and browse to the hex file. So this is the hex file which the software created based on my RGB file. I can open it. Yeah, so okay, let's go here, debug and RGB hello2.hex, and just program it. So it will take a while. It will tell you like it's programming the flash. After programming, it verifies the flash, and once it's verified, it's okay. So now the program which is running is the one which you wrote, and that is basically programmed to fade in and fade out the RGB LED. Now you can, in an ideal way, you can like go, if you have more time, you can go and try to modify this code and then see how the code is behaving with your LED. So this is like a again quick demo of how to create a new project, how to create a C file, then how to write it, and then how to program it. To learn C file, you can basically just Google like AVR microcontroller C programming, and there's like plenty of examples available. Okay. So after that, I am installing Eagle file in it, Eagle software in it. Once I have the Eagle software, I would suggest that this computer and that both computer have Eagle installer in them, and there is also you can download it from internet. So if you just go to google.com and do Eagle cat soft download, you can go here, download Eagle. So again, you can download the version according to your operating system. Once you do that, then I can quickly show you how to make the circuit diagram and then the PCB. So that will complete almost 3 weeks of Fab Academy, again in a very short time. Classes. So that will be electronic production. I just covered the embedded programming, and then we'll cover I just covered the embedded programming, and then we'll cover the electronic design. So that will finish up with the electronics part of it.